Welcome. Morning, everyone. I think this talk, following from what Pascal mentioned, is going to be a talk on how we use these APIs and my perspective on the criticality of APIs and digitization in the industry and a little bit of what we're doing. So in my talk today, I'm going to describe a couple of key concepts and what we brought to market. So we announced something called Private Connectivity Fabric. And look, it's an architecture. And I'll describe more why a network architecture change is necessary in the industry today. But where I want to go next is that it needs to be delivered digitally from a platform. And so that's a major change we've made in the delivery of our products. And then I'm going to speak for a moment in just a couple slides that network as a service for me is a consumption model. It's not a technology. And so I'm going to, throughout my talk, I'm going to make several bold claims proved only through emphatic assertion. But nonetheless, it's really meant to catalyze the differences we have and the different views we have of how to use APIs, how to build networks, and how to build ecosystems around the digitization and cloudification of the network. Now, as was mentioned earlier, you can't have a talk in 2024, or perhaps 25, and maybe 2026 and beyond, without talking about AI for a moment. And we're taking a big role in the construction of AI data centers by a major construction projects that we have going on this year, next year, and the next couple of years, bringing an immense amount of capacity, bandwidth, and fiber into the network. And so we've made several announcements towards that, and I'm not going to talk about them today. But what's critical for an AI strategy for any enterprise is understanding who your data center and cloud partners are going to be. Second, you have to have a data management strategy. But this is a networking conference. And I want to say that what's really been missed in the conversations is that you have to have a networking strategy of how to move this data to be trained or in inference, or in reinforcement. And that networking piece is why we're all here this week, and why we're talking about the need for the APIs and digitization. So this is outstandingly obvious to everyone in the audience, but fiber and wave connectivity is critical for the bandwidth solutions that are required today. Again, getting data to the data centers, getting data in between data centers and cloud. The evolution and discussions around cloud on-ramp to AI on-ramp and creating a network architecture that satisfies those AI workloads is the conversation we're all going to be having. Now, we're putting, as I mentioned, immense amount of fiber into the ground right now. To put it in perspective, the amount of fiber in the construction projects will reach from Earth to Venus. So we're not talking about just a couple thousand cable routes or a couple thousand fiber routes, but tens of millions and over 100 million fiber miles are going into the ground. So it's an immense increase in capacity in the continental US of bandwidth, and perhaps the largest expansion of the internet I've seen in my lifetime. So let me just kind of put this in perspective. 400 gigs are in immense demand. Any company that's working in or associated with AI is coming to us asking for dozens and hundreds of 400 gig waves at a time. It is no fooling amount of bandwidth. 800 gig, 1.6T can't get here fast enough because of the spectral efficiency as well as the concatenation of links to move this traffic is necessary. So you've seen many of my colleagues in the industry at different companies doing various hero experiments, but we're going to go through 400 and hit 800 as soon as it gets off the loading docks of the system integrators, and 1.6T in the wide area network, which is what I'm talking about, can't get here fast enough. Fiber and dark fiber creating MOFN networks or managed optical fiber networks, lit and wave services, it's critical to creating connectivity to these AI data centers. And just to put it in perspective, and this is a little bit of sloppy math, but to put it in perspective, you can get a cable now, 864 fibers in that cable. And I have enough gray hair coming out of my head. I can remember when I was surprised that we could fit 144 and 288 fibers in those cables. It's now 864. Suppliers are putting 1728 fibers, so you can multiply this by 2. But just using an 864 fiber cable, it's 45,000 terabits. That's about a little bit more, 100,000 400 gig waves. So we went from gigabit to terabit to shalotabit really, really fast. And so to meet the demand, I posit that the amount of fiber in the ground and the amount of data centers being constructed as an industry, as far as we can predict forward, let's say is about 7 to 10 years. This is a 7 to 10 year horizon. But the internet architecture today doesn't match the need. And so I'll talk about that in just a moment. What you see in the map of the continental US is where, you can see the power corridors that are emerging. You can see by the size of the circle, the number of gigawatts that are of data center parks that are being constructed around the US. This is the new internet architecture. As we know in the industry, once a data center is built or a data center park is built, an entire ecosystem and economy grows around it. Distribution centers, tier 2, tier 3 data centers come into that space and construct new buildings, et cetera. These are the new hubs, and what obviously everyone can see, these are not in major metropolitan areas. It's where power can be supplied by renewable resources and where real estate is at a price point that actually can be afforded to build out these data centers. And you can see these major hubs. Now, what becomes critical is our understanding and change in network architecture terms of truly the emergence of hybrid AI architectures. And we know this from enterprise space, where we used to talk about hybrid cloud architectures of prem to private data center or prem to CSP or cloud service provider. The exact same thing is happening from day zero in the AI world. The traffic patterns that are emerging are not necessarily moving all the data from prem because it's potentially already in a private data center or already in a cloud. These network architectures become critical for all of us who are building new ways to automate, orchestrate network-to-network interfaces, network-to-cloud interfaces, and so forth. And I have a couple more points I'm going to bring up. The main one, and I am completely drunk on my Kool-Aid after being in the industry for a little while, that the architectures and technology that we helped to build in the 90s and early noughts and even into the teens of this century are completely maxed out, and they are the wrong network architectures to build high capacity networks. A couple things, I'm going to jump down to my third bullet. The notion of a provider edge being a hub to create spokes between enterprise prem, wrong construct. That's an hourglass design. It's immediately capacity limiting and immediately increasing latency. Second, the notion of where we've constructed meet-me rooms, carrier hotels, fiber hotels on the internet, whether it's 350 Cermak, 56 Marietta, Hudson, the classic legacy telephony architecture where telephone companies got together to be able to initiate calls between themselves now have emerged as cloud on-ramps because it was easy. And CSPs needed immediacy to be able to connect to a multitude of carriers to get customers to their cloud. So we all understand how this happened, but think about history for a moment. May East and May West were the most important locations on the internet in the late 90s and early 2000s for BGP peering. Those architectures have been fully distributed out to the regions and metro area for metro-based peering, whether it's settlement-free or it's paid peering. We are going to see, and we are all going to help build the distribution of the carrier hotels and fiber hotels. Recall in your memory the picture I had of the US. So we're going to pull a metric boatload of fiber to these data centers. Carrier hotels have not been invented in those locations. Data center interconnect has not been invented in those locations. Splice points have been defined. Now, how are enterprises going to get in and out of that data center? How is the data in that data center going to get a CSP? How is data in that data center going to get to some other provider's data center somewhere else in the world? As enterprises have created full multi-cloud architectures already today. So a notion that there's a clear alliance, allegiance, or brand stickiness, I believe needs to be removed from our network architectural discussions, because it's really where's the data located and where's the data moving. And the network needs to respond to that. And that's why we're building on-demand networks. And that's why we're automating and orchestrating to meet workflows, whether they're AI or enterprise IT, and data flows of wherever that data needs to be, because people change their mind. They make new partnerships. They decide to go to a new location and go with another data center partner. It's the way the world works. Our network architectures have to reflect that. Wherever I am in my bullets, rings are for marriage, and they're not for network architectures anymore. And I think we all know within our own companies, if you build metro rings and you build a hub and spoke architecture, you have immediately stranded capacity, created traffic flows, and I can show in my own network, by moving to a routed optical network, I can get an order of capacity, an order increase in capacity out of the existing fiber in the ground. And I can show over an order of magnitude decrease in cost to deliver photon and bit. And so the architectures of the 90s and early noughts, as much as we love them and as much as we all built technology for them, they are not fit for purpose in a high bandwidth, low latency world. And as I mentioned, look, it's time to get meshy. It's time to realize that a notion that an enterprise is defined by the locations that they occupy and the sites that they occupy as their real estate is not the way the world works. They have more data in cloud than they have on-prem. In cloud, for me, means private data centers. Their workloads are running in a variety of clouds. And these multitude of clouds, including storage, security, UC, SaaS offers, that's where IT is running. So this notion of building hub and spoke to pieces of real estate associated with the enterprise, again, don't match the workflows and data patterns of how that enterprise is constructed now. I'm a networking guy, so I have this crazy belief that an enterprise is defined by its communication topology. And if you take that as a way to think about what the boundaries of an enterprise IT system are, then you realize that it's not bound on that real estate anymore. Instead, it's been moved off-prem. So I have something a bit contentious for some of my friends in the room. I have this belief in SD-WAN and SASE have been a beautiful thing for the industry. Simplifying IT, fantastic user experience, reducing friction of moving IT workloads, etc. But SD-WAN and SASE, in my argument, over general broadband links, is not fit for purpose in a high bandwidth world. And so this might not be a very difficult leap to make, but tying SD-WAN and SASE to an underlay, whether it's Waves, Ethernet, or dedicated IP, will give bandwidth control, latency control, redundancy control through the elegant SD-WAN and SASE user interface. IT people love it. Keep that going. SD-WAN and SASE built the first interface that delighted their customers. But in this new world that I'm describing that exists today, the tie to the underlay services is critical for the bandwidth, latency, and redundancy guarantees. And so to my point, we're here to discuss APIs, how to make that happen. And that is the ecosystem of partners that now emerges in the economy, where everybody has a role and everybody has space and we can stay in our lanes and we can all be profitable, increase revenue, et cetera, but we do have to realize this is now the new ecosystem of internet partners. And I'm going to jump back up one bullet, as SD-WAN and SASE was deployed initially with gateways in CSPs, that creates a tromboning of traffic potentially. That increases latency, decreases user experience, and completely is in the way of getting to AI clouds. So we have a new construction in the internet architecture of where these SD-WAN and SASE gateways are going to be located. Edge clouds are a wonderful place. So we're at a conference talking about APIs, automation. What I want to focus on is self-service. And I want to focus on creating that ecosystem of partners where if I'm building a digital platform to deliver the consumption of Waves, Ethernet IP, private IP, and my telemetry products, I realize that my partners may be the ones with the customer relationship. My goal is to make that as easy as possible to consume those APIs, which is why I'm here at MEF. We all know this, we understand this. Pascal said it very, very clearly. The interesting piece may be the bottom of the slide, which is the composability of these products. The notion that we have, as has been laid out by MEF, of ports, services within the port, the notion that MEF brought to the industry and has worked very hard towards of multi-service uniports as the definition of the product description and the service description is the path forward. It decouples the service from a geographic location or a topologic location in the network and has it associated with the port that the customer wants to consume on. And that becomes key for the future. So we know that digital platforms, and MEF has LSO, because these digital platforms are multi-layered. Like me, I'm sure you all have internal representations of your systems, and you have a need for external representations and bindings to different languages, and converters and translators. And again, perhaps a bit contentious in this organization, but there was some interesting press announcements yesterday. Translators are necessary. Standards may not move fast enough. Partnerships may need to move faster. And additionally, nobody wants to code to my representation, my APIs. Super easy for me to go API crazy, 100,000 APIs for this, that, and the other thing. No, we need the ability to aggregate these into very clear objects we want to manipulate. And so these translators become key and also can follow the needs of the developer community and the integrator community to build larger platforms of platforms, et cetera. And we haven't gotten to that discussion yet as an industry, but we will. My next posit is that NaaS is a consumption model. We should not confuse it with a technology. It is not a protocol. It is a consumption model to be able to enable a customer to consume the connectivity between the locations they want and have different ways of consuming it. A notion of commercial commit, commercial burst, different terms. It's just a way, like in cloud, to deliver a consumption model. It is the push that we have used as an industry, whether we admitted it or not, as the catalyst to transform the telco industry. We have to realize that we're doing all this digitization for a number of purposes, and we also need to realize which benefit we're trying to get. I would like to get reduced cost of sales. I'd like to have a new sales channel, integrate with my partners, et cetera. But the customer wants a frictionless way to design, quote, consume, understand their billing, understand if their SLAs are being met. And it's really that overall friction reduction that we're all going for as an industry. So with just a few minutes left, what I've been working on and where the network is going is that we need to make data centers and clouds first-class citizens. Our signaling and routing protocols are not fit for purpose, which is why APIs have a place. I'll give you a quick example. In MPLS, we signal from head to tail. I'm an enterprise, I want to get to cloud, I'm going to signal from enterprise to cloud. How do workflows work? You instantiate your VPC in the cloud first, and then you want to create connectivity. our signaling protocols don't work in that environment. We need to recognize this and realize that there's limitations to what those routing protocols and signaling protocols can do, and use the power of the APIs on top. As I mentioned, network architectures need to match workflow patterns and data movements. Network as a service, as a consumption model, is moving all the way to on-prem, into network interfaces devices, into CPEs. This allows from prem, whatever that may be, including an enterprise piece of real estate or a data center, bandwidth, latency, and redundancy programmability across that network end to end. Promised by MPLS, never delivered. And then the last 2 points very quickly. The network economy has matured. There are now segments within the cloud economy. And I mentioned this before. We have storage clouds, security clouds, UC clouds, SaaS clouds. These CSPs and businesses are beginning to niche or have fully niched. And we need to recognize this, that the new network-to-network interface and the new fabric that we want to build is within those segments of the economy that's emerging. And last, the transport exchanges have emerged in the industry where large data collaborators are coming together at dozens of 400 gig waves at private exchanges, transport only, and this has become a new form of peering. And it's transport peering to exchange this data to the tune of dozens and hundreds of 400 gig waves being brought to these exchange points. So it's a lot of data that's being exchanged. And so my last point, or in sum, MEF is critical because it's the way that we're going to come to meet together to understand how to describe each other's networks to each other and to be able to create an ecosystem of partners. And so I'm using that technology purposeful for my business. Hopefully this has been an interesting talk for you all this morning on how I'm using MEF and where I see the network going. So thank you very much.